Right, we are here and we want to evaluate the integral of the cosecant of x with respect to x. And to evaluate the integral of the cosecant of x with respect to x, we present a solution to this particular problem, but in a step-by-step fashion as follows. Right, so we have the following. Right, first, the integral of the cosecant of x with respect to x. And this is the integral of cosecant of x, and we multiply by cosecant of x minus the cotangent of x, and we divide by cosecant of x minus the cotangent of x with respect to x. Right, and upon multiplication by this, because this is a 1, and now we proceed as follows. Now multiplying the numerator terms with cosecant of x, we'll get cosecant by cosecant, which is cosecant squared, and cosecant of x times the cotangent of x, which becomes minus the cosecant, the cotangent, and we write the following. Right, so we write cosecant squared of x minus cosecant of x times the cotangent of x, and you divide everything by cosecant of x minus the cotangent of x with respect to x. We let u to become the cosecant of x, the cotangent of x. Right, so we let u to become cosecant of x minus cotangent of x. And we proceed to then find the derivative du dx. Right, the derivative of the cosecant of x is the same as what? Is the same as minus the cosecant of x, the cotangent of x. And the derivative of the cotangent of x is minus the cosecant squared of x, like so. Right, meaning therefore we proceed to write the following. Du dx is minus cosecant of x times the cotangent of x minus cosecant of x, the cotangent of x, plus the cosecant squared of x. Right, so at this point, we proceed to make dx the subject of this particular equation. So if we make dx the subject of this particular equation, what do we get? Right, so we're able to see that dx is du divided by, right, so dx is du divided by, so we can start by writing here cosecant squared of x minus cosecant of x times the cotangent of x, like so. Right, and we proceed to check carefully. So upon careful examination, we perform the substitution. Right, so what substitution do we perform? So we write this last bit of step. So we write the following step, this one, okay. So we write here the last step we got, which was the integral of cosecant squared of x minus cosecant of x, the cotangent of x, divided by the cosecant of x, the cotangent of x, dx. Now, focusing actually on the denominator, we know that we have decided to make the denominator u, and the numerator remains the cosecant squared of x, the cosecant of x, the cotangent of x. And then now, what is dx? What is dx? Right, so we take dx from here. Dx is du over cosecant squared minus cosecant of x times the cotangent of x. So we put here du divided by the cosecant squared, the cosecant of x, the cotangent of x, like so. Right, and upon careful examination, we're able to cross this out, and upon crossing that out, we have therefore that this is the integral of 1 over u du. 1 over u du. Okay. And then now, what is the integral of 1 over u du? Let's examine that one. The integral of 1 over u du is the natural log of the modulus of u plus the arbitrary constant of integration c. We remember that u was just what? We remember that u was cosecant of x minus the cotangent of x. So we write here cosecant of x minus the cotangent of x, right, plus c. And then what is the conclusion out of this? We write the following step. Hence, the integral of cosecant of x dx is the integral right of the cosecant of x minus the cotangent of x plus c. Okay, so we just take note of these here. Right, and so this concludes the first part, or concludes whatever we had to do. We had to just find the integral of cosecant of x with respect to x, and it is nothing other than the natural log of cosecant of x minus the cotangent of x in modulus plus the arbitrary constant of integration c. Okay, now there are a couple of things that we need to do. Now, there's another method that we're going to use to solve this particular problem. Let's use another method. Right, in other words, if you have the integral of cosecant of x with respect to x, what do? We can multiply. Right, you can multiply by what? Right, we can choose to multiply by cosecant of x plus the cotangent of x divided by the cosecant of x plus the cotangent of x dx. So now when you multiply, you have cosecant squared x plus cosecant x, the cotangent of x, divided by cosecant of x, cotangent of x with respect to x, like so. Right. And upon careful examination, we proceed to let u to actually become the denominator. So let u be equal to cosecant of x plus the cotangent of x. So let u be equal to the cosecant of x plus the cotangent of x. And therefore now du dx, what is the derivative of this? Now the derivative of the cosecant of x is minus the cosecant of x, the cotangent of x, and the derivative of the cotangent of x is minus the cosecant squared of x. And now at this point, we proceed to make dx the subject of this equation. And so, which means that dx is equal to du divided by. Now, this denominator we factor out. And if we factor out and we just reorganize the terms a little bit, factoring out a negative from this would actually therefore give us the cosecant squared of x plus the cosecant of x, the cotangent of x, like so. Okay, and this is what we get. And upon careful examination of this, we're able to perform substitution of these into the previous step, this particular step. So we carry this step forward, right? So we proceed to write the integral of cosecant squared x plus cosecant x, the cotangent of x, divided by the cosecant of x, the cotangent of x, dx. So, and then, if we perform the substitution, the denominator is just u, and the numerator is the cosecant squared of x plus the cosecant of x, the cotangent of x. And now this is what we have, but we proceed to multiply these by the expression that dx equals. What expression does dx equal? Dx equals du over the negative. Right, so it is du over the negative, this, which is negative the cosecant squared x plus the cosecant of x, and we multiply there by the cotangent of x, and we close the bracket that way. And upon careful examination, we're able to take note of the fact that this whole expression cancels that whole expression. And upon cancellation, we obtain what? Right, you can pull out the minus outside the integral sign because the negative is can be pulled out as a constant, giving us 1 over u, right, giving us 1 over u du, 1 over u du. And then if you have minus the integral of 1 over u du, what is the integral of 1 over u? It is the natural log of the modulus of u plus c. Okay, minus the natural log of modulus of u. What is u? U is actually cosecant of x plus the cotangent of x plus c, like so. And this is what we have. All right, now, the couple of things that remain extremely important for us to take into account. So we proceed to then say, hence, right, hence. Well, hence the integral of the cosecant of x with respect to x. This integral here is the natural log of cosecant of x plus the cotangent of x plus c, like so. And so this integral of the cosecant of x with respect to x is negative the natural log of the cosecant of x plus the cotangent of x plus c. We proceed to do further investigations. Now, we have got results of this. So now let us do a bit of comparison here. I'm going to write the following step. Thus, the integral of the cosecant of x with respect to x is the natural log of the cosecant of x minus the cotangent of x plus c. And it is the natural log of, it is minus the natural log of the cosecant of x plus the cotangent of x plus c. All right, so that is what we have. So now we have got that the integral is two expressions that are equivalent but look different. The answers look different because here the integral of the cosecant of x with respect to x is the natural log of the cosecant of x minus the cotangent of x within modular signs plus c. And here we have that the integral of the cosecant of x dx or with respect to x is equal to minus the natural log of the modulus of the cosecant of x plus the cotangent of x plus c. Okay, so we have two results. These two results are most certainly equivalent results there. Okay, now let us proceed to do further analysis of these. But now this integral can also look a little bit different. Okay, now let us analyze it because somebody can do it differently. Let's do it differently. Okay. Right, we can use another method. We can use another method to do this integral. So here we are looking, let's do this. Okay, so we started here. Right, we started here and this became method. It became method 1. Next. So in method 1, we multiplied by the cosecant of x minus the cotangent of x over the cosecant of x minus the cotangent of x. Okay, so next. Now we got a result. Here we have method 2. Right. In method 2, we multiplied by the cosecant of x plus the cotangent of x, all divided by the cosecant of x plus the cotangent of x. And that became method 2. Became method 2. And with method 2, we got these results. And we're able to write a conclusion that the integral is minus the natural log of the modulus of the cosecant of x plus the cotangent of x plus c, the arbitrary constant of integration. Okay, so, and therefore here we went on to compare the two results. Right, next. I want us to use another method. So we have gone up to method 2, and then now this one here is method 3. Method 3. Right, using method 3, we are still looking at the integral of the cosecant of x with respect to x. Okay, the couple of things that we can consider, but something that is very, very important is the fact that the cosecant can be written as 1 over the trigonometric sine of x with respect to x, like so. And now we have this. Okay, so we have this. And you have this. Right, so you can put x over 2 here. And use the substitution that says that you can let t be the tangent of x over 2. So that now here you put x over 2 and the tangent is most certainly opposite over adjacent. And therefore, by using the Pythagorean relation, this is the square root of this, 1 plus the square root of 1 plus t squared. The square root of 1 plus t squared. Like this. Okay. If this is the case, you can write here. Let's write this step here so that we write very clearly. We don't want things to get mixed up. Right, so we let t be the tangent of x over 2. Okay, if this is the case, we proceed to express the sine of x in terms of t. So we write sine x. Right, so sine x can be written as the sine of double x over 2. And this is 2 times the sine of x over 2, the cosine of x over 2. And the sine of x over 2 is opposite over hypotenuse, which is t over the square root. Right, so here the sine of x over 2 is t over the square root of 1 plus t squared. The cosine is of x over 2, cosine x over 2 here is cosine of x over 2 is adjacent of hypotenuse, which is 1 over that. 1 plus t squared. So you have the sine of x, which is 2t divided by 1 plus t squared. Okay. And so now, if this is the case, we perform substitution. But we take note of the fact that also t is the tangent of x over 2. And we can find the derivative of this. Right, let us find the derivative with respect to x, which is, okay, so the derivative of the tangent is the secant squared of x over 2 by the chain rule, and we find the derivative of x over 2, which is just 1/2. And then now, at this pointer, we want to make dx the subject of this particular equation. Let's make dx the subject of this equation. So dx is going to be the same as what? Is the same as dt divided by 1 over 2, the secant squared of x over 2, like this. Right, so now we have here the integral of 1 over sine x dx. So if you have the integral of, okay, so we can write a little bit more steps, that the integral of cosecant of x with respect to x is equal to the integral of 1 over sine x with respect to x. Right, and upon careful examination, we're able to see that 1 over the sine of x in terms of t is the same as 2t over 1 plus t squared, which is 2t over 1 plus t squared dx. Dx is the same as what? As dt over 1/2 of the secant squared of x over 2. So dx is dt over 1/2 of the secant squared of x over 2. Okay? So now, let us continue to analyze these and see what we have here at this point. Right. What do we have here at this point? What is t here? What is t? So in other words, this is equal to, right, we have the integral of, now this here can be inverted to 1 plus t squared over 2t, 1 plus t squared over 2t, and then you have dt over 1/2, but now this one can write as 2 dt. 2 dt over the secant squared of x over 2. Just write that one down. Over the secant squared of x over 2. Okay? Which is 1 plus. Now, the t is the same as what? T is the same as the tangent of x over 2, but this is squared, and this is divided by 2 times the tangent of x over 2. 2 dt divided by the secant squared of x over 2. What is 1 plus the tangent squared? It is the secant squared. So this is 2 times the secant squared. So you have 2 times the secant squared of x over 2, right, dt, divided by, right, so in the denominator, you furthermore have what? You have 2 the secant of the tangent, right? 2 the tangent of x over 2 in the denominator, 2 the tangent of x over 2. And then here you have the 2 dt. Let us check this one. Yeah. Okay. And then you have the, in the denominator, you have 2 the tangent, right? And then you have the secant squared. We have the secant squared of x over 2. Right. So this cancels that. And now, if the secant cancels in that manner, what then do we have here? Let us check. Let us check very, very carefully what we have here. Right, let us check what we have. So we're going to have, okay, these two cancels as well. So when these two cancels, we have that this equals. Right, let's check what this equals. Checking very carefully. Right, because this secant squared of x over 2 cancels the secant squared of x over 2. That's okay. And the 2 cancels out, leaving us with the dt over, right, the tangent of x over 2. Okay, and we remember that the tangent is 1 over t dt, and this is the natural log of t plus c, and this is the natural log of the tangent of x over 2 plus c. Okay, that's what we have. Okay, so that's what we have got. In other words, so we say hence the integral of the cosecant, right? Hence the integral of the cosecant of x with respect to x. It is also equal to, the natural log of the tangent of x over 2 plus c. Right, we used method 3, and this is the result. And this concludes the solution to method 3. And then we can proceed to say thus. Thus, the integral of the cosecant of x with respect to x. This is exactly the same as what? Right, we found 3 results. What are the results? The first result. The first result is the natural log of the cosecant of x minus the cotangent of x plus c. The second result, you have the cosecant of x plus the cotangent of x plus c. And also, we saw that this integral here is the natural log of the tangent of x over 2 plus c. So we've got these 3 results, but all these are equivalent. So in other words, we have got that the integral of the cosecant of x dx is the natural log of the tangent of x over 2 within the modular sign plus c. Or this integral is also equal to the natural log of the cosecant of x minus the cotangent of x plus c. Or we have that, or this integral of the cosecant of x with respect to x is minus the natural log of the cosecant of x plus the cotangent of x plus c. There are more things that we can establish about this integral here. But now we proceed to state also another version of the result. Right, we want to just explore this one for now. Let us do some more exploration. The integral of the cosecant. So we proceed to say moreover, if we have the integral of the cosecant of x with respect to x, it is the natural log of the cosecant of x. Just write that one, cosecant of x minus the cotangent of x plus c. What is cosecant of x? Cosecant of x is 1 over the sine of x, and the cotangent is the same as cosine of x over the sine of x plus c. So yeah, the denominator is the same here. In the numerator, you have 1 minus cosine x divided by the sine of x plus c. And we proceed to do the following. Now, you have 1 minus cosecant of x. What is sine x? Right, there's something we need to just remember. Okay, we know that sine squared x plus cosine squared x is 1. So that sine squared x is 1 minus cosine squared x. Okay. And therefore, sine x is plus or minus the square root. 1 minus cosine squared of x. So that in the place of the sine, we can put plus or minus the square root of 1 minus cosine squared, like so, plus c. Right. And so the modulus of this, the modulus of plus or minus is just plus, so that you have 1 minus the cosine divided by the square root of 1 minus cosine squared plus c. And this is then equal to the natural log of 1 minus cosine x divided by, now the 1 minus cosine squared is 1 minus, because we have 1 minus cosine squared x in the denominator, which is 1 minus cosine x, 1 plus cosine x plus c. Okay. And so what is this? So this is the natural log of 1 minus cosine x divided by, okay, you have here 1 minus cosine x. Here you have 1 plus cosine x plus c. Right, so now you have 1 minus cosine x, you divide by this. So you can view this as to the power 1, and this one is to the power 1/2. So you would have 1 minus 1/2. So in other words, you have 1 minus, the bases are the same here for this. So it's 1 minus 1/2, which is just 1/2, divided by the square root of the plus. But you can write this one also. Let's write this one as 1 plus cosine x to 1/2 plus c. And therefore, this equals the natural log of 1 minus cosine x. Okay, so obviously you have to the power 1/2 to the power 1/2. So 1 plus cosine x. Right, so it's 1 plus cosine x. Like so. Okay, so we took the common power 1/2, getting exactly this, which is 1 minus cosine x divided by 1 plus cosine x. And you can you pull out the power 1/2 plus c. Now that power can be brought down so that we have 1 minus cosine x divided by 1 plus cosine x plus c. So this also, in other words, we're able to say hence the integral of cosecant of x with respect to x. We've already seen that it is the natural log of cosecant x minus cotangent of x plus c, but this is equal to 1/2 of the natural log of 1 minus cosine x divided by 1 plus cosine x plus c. Right, so this is very, very important. So in other words, these are equivalent. Right, meaning we can write the integral of cosecant of x as this one or as that one. And now we are able to write the following conclusion. Henceforth, right, thus, the integral of cosecant of x, right, the integral of cosecant of x with respect to x. We've already seen that this integral is the natural log of what? It is the natural log of cosecant x minus the cotangent of x plus c minus the natural log of cosecant of x plus cotangent of x plus c. And it is also the same as the natural log. Right, it is the same as the natural log of the tangent of x over 2 plus c. But it is also the same as the 1/2 of 1 minus cosine x divided by 1 plus cosine x. Like this. So in other words, the integral of the cosecant of x is the same as the natural log of the cosecant of x minus the cotangent of x plus c. Or it is minus the natural log of the cosecant of x plus the cotangent of x plus c. Or the integral is also the same as the natural log of the tangent of x over 2 within the modular sign plus c. Or this the integral of the cosecant is 1/2 of the natural log of this up here. So in other words, we cannot get tired of writing like this. The integral of the cosecant, one of the most popular results is the first one with the minus. Natural log of, and you can write it here, we like, right, you can write it here and say it is the natural log of cosecant of x minus the cotangent plus c, which is cosecant of x plus the cotangent plus c. Or we can say it is also the same as what? You can say it's also the same as the natural log of the tangent of x over 2 plus c. Or it is also the same as 1/2 of 1 minus cosine x 1 plus cosine x plus c. So we have this particular result. So the integral of the cosecant of x with respect to x is the natural log of the cosecant of x minus the cotangent of x plus c. or it is minus the natural log of the modulus of the cosecant of x plus the cotangent of x plus c, or it is the natural log of the tangent of x over 2 plus c, or it is equal to 1/2 times the natural log of 1 minus the cosine of x divided by 1 plus cosine of x plus c. Okay, so we have these particular results that we have established, but in each case, what we have is it is the integral of the cosecant of x with respect to x that equals this. It is the integral of the cosecant of x with respect to x that equals that. It is the integral of the cosecant of x that equals that as well. So the integral of the cosine of the cosecant of x can be written in the four different ways that we got. But there are much more than this in general in mathematics, and much more equivalent solutions can be found and can be written down and can be proven as integrals of the cosecant of x with respect to x. Thanks everybody for your time and attention, and goodbye to you.